Okay, so today we're going to be talking about how we solve systems of equations and systems of inequalities. Okay, so we're going to kind of roll two things into one. This is review from 9th grade, so none of this should be new. So we should be able to move relatively quickly. We're going to do it both algebraically as well as graphically. Ready? All right. Next page. Control over. There we go. All right, so we're going to solve the system of equations below. Then we're going to graph the two equations on 1.4. So we're going to do it algebraically to start. Check it graphically. Who remembers what the solution to a system of equations is? It's where they meet. What do you mean it's where they meet? Where they intersect. So the solution is a what? It's a point. It's an intersection point. Okay, good. So here's our system. We are going to solve algebraically first. Okay? Okay, so if both of these equations is y equals, how would I go about solving this system? Algebraically, yep. Plug in the y for the other y. Give me another way to say that. Sure, substitution. I would substitute what y is equal to. Hello. That's odd. So I would substitute what one y is equal to in for the other y. Another way to say that, thank you, we set them equal to one another. Okay? 2x plus 4 equals negative 3x minus 1. Setting them equal to one another. Okay. Now what? Add 1. Okay, we can add 1. There's many ways to do this. All right. Oop. Subtract 2x, okay. Very good. So I get negative 1 equals x. Am I done? Why not? Yeah, I've got x. I need y because remember the solution is going to be a point or multiple points, okay? Which means if I have a y, I have to have an x and vice versa. Okay, so I've got negative 1 for my x. Which equation should I use to find my y? Just one. Doesn't matter what one? No, you always want the easier one. Sure, the first one works for me. So we have y equals 2 times negative 1 plus 4. Or y equals negative 2 plus 4, which gives me 2. So we've got negative 1, 2 as our solution. We're going to do what with that? We're going to graph it to check it. Now, we could graph it using store to make sure that the point is correct. We'd have to check it into both equations, but it's easier to just graph them and find the solution that way. Okay, so that's what we're going to do next. Are you guys ready? Okay, I'm waiting. That's okay. Okay, so we're going to solve this graphically now. Okay, so you've got your graph page. It's on 1.4. We're going to graph our first equation, 2x plus 4. Okay, you're going to hit enter to graph it. So everybody should have this in here, 2x plus 4, graph that line. How do I bring back up my function bar in order to graph another line? Control G. We're going to graph that second one, negative 3x minus, hello, negative 3x minus 1. And we're going to hit enter. Thank you, Ludmila. Nope. We're not going to use the table for this. Okay, so we said the solution is the intersection of the two lines, right? The point where it intersects. So here's how we get that intersection. Are you ready? Pay very close attention. You're going to do this when I do it. Are you ready? Yes. Hit menu, please. Geometry. Points and lines. Intersection point. Menu, geometry, points and lines, intersection point. This is really easy to use. Here's what you do. Are you ready? You're going to swipe and click on the first function. Swipe and click on the second function, and that intersection is going to pop right up for you, negative 1, 2. Were we correct? Perfect. Okay, so how is the point of intersection related to the solution of the system of equations? How is the point that we just found, the intersection point, related to the solution we found algebraically? They're the same, right? The intersection point is the solution, okay? All right, so let's try one that's linear quadratic. We're going to do this one. We're going to do this one only graphically. We're not going to do it algebraically, just so that you're comfortable with that graphical model. All right, so graphically only. So I want you to do this on your own. You're going to graph these two functions, find the intersection point or points depending on what we have, and then we'll go over it together. So go ahead and give it a shot. Okay, so we're going to graph both of these. X squared plus 3x plus 2, right? And then our next one, oops, that's not what I wanted. Control G, we've got negative 2x. Why does it keep doing that? I'm graphing a line. What are you doing? Okay, so what's the problem with this?
You can't see the upper one.
Can't see that second intersection, right? So here's what we do in order to change our window, because we need to see more of our second quadrant. Agreed? Okay, so here's what you do. Are you ready? Pay attention. We're going to double click on that negative 10 until it opens the text box. Okay, double click so that it opens the text box. I'm going to change this to about negative 8. Don't hit enter, just wait. Okay? It will. If you have a tool up, hit escape first. Hit escape and then try it, okay? I'm going to hit tab to come up to my y maximum. I want to see more of that, right? What do you think we should change it to? Give me a number. 15. I'm going to hit tab again. Do I need that much on my x? I'd probably make it 5. And that's good enough. Can I see both intersection points now? Yeah, okay. So that's how you're going to adjust your window so that you can get both intersection points in there. All right, now how do I do this? Menu. Geometry. Points and lines. Intersection points. So click, click, and they both pop up at once. Okay? I would like you to round your answers to the nearest tenth. To the nearest tenth, please. And since there's more than one solution, we use curly brackets. Okay? So we should have negative 4.8, 10.6 is my first solution, negative 0.2 or 2/10, and 1.4. Are we okay? So graphically it's pretty easy, right? No problems with that. It's algebraic that takes more time. All right, so you ready to try another one? Everybody okay if I move on? Okay. Next page, please. So here's my next one. I've got 50 equals x squared plus y squared, and y equals x. Who could tell me what type of relation this is, or what type of equation? What does that represent? Nope, it's not a quadratic. It's a what? Nope. Bless you. Think geometry, guys. You learned this in the geometry. What is that? X squared plus y squared. What is it? It's a circle. Circle with a center of what? 0, 0, the origin. And what's the radius? Square root of 50. Square root of what's there. Do you remember? Is it all flowing back in? Beautiful circle. We love them. We don't hate them. Okay, so we are going to solve this algebraically to start. All right, how am I going to do this one? Are they both y equals? I need another method. Absolutely, substitution. I know that y is equal to what? X. So why can't I just plug in x where I see y? I can. So 50 equals x squared plus x, right? That's going in place of my y squared. Substitution, that's what it's called. Absolutely. What's x squared plus x squared? 2x squared. I'm pretend like I didn't hear that, okay? All right, now what? 5 by 2. Okay? Good. What's the square root of 25? And plus and minus 5. Remember, whenever you take the square root, it's always plus and minus. Always, 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 always. Is it always?
Yes.
Thank you. Okay, it's always plus and minus. So we have the start of two solutions here. I've got a 5 and I have a negative 5, right? What do I need to find? I need to find the y's. Which equation should I use? Yeah, probably the y equals x. I mean, that'd be the easiest bet, right? So the first one, y equals 5. And the second one, y equals negative 5. So my solutions are 5, 5, and negative 5, negative 5. I have an answer.
What if you put the negative 5 without 5?
No, then it'd be wrong. Okay. Okay, so we're going to check that graphically. You guys ready? Okay. All right. In order to graph a circle, it's a little bit different. So please follow along with my steps. Menu. Graph entry edit. And it is an equation. Notice it has a picture of an ellipse there. So an equation, and we're going to choose circle. Which one? The top one. Good. Okay, so it says x minus and then a blank box. What's going to be in there? 0. And then my next blank box is going to be 0 because I know the center is at 0, 0. This is center radius form. Be careful. Something squared. I want you to think logically, guys. Right now, it's 50, okay? It's equal to 50. Who said it? Say it again. Yeah, the square root of 50 squared would be 50, right? So we have to write it as the square root of 50. Square root of 50. Come on. Graph it up. It's pretty, isn't it? It is pretty. It is too. Beautiful circle. Okay, we got another thing to graph here. Y equals x, right? So Control G to bring up that function bar. Why is that there? Because right now we have it set to graph circles. So go back to menu. Graph entry edit. Function. And we're going to select x. And there it is. So go ahead and use your tools to find my intersection points. All right. Okay, so you should have menu, geometry, points and lines, intersection point, click, click, negative 5, negative 5, 5, 5. Are we good? Questions, problems, concerns? Moving on. Next page. Okay, this one's a little bit uglier, right?
Yeah.
Yeah, it's a little uglier. That's okay. It's not that big of a deal. All right, so I need to solve. Are you ready? Okay, we're awfully chatty. All right, so let's go ahead. I want you to think about how we would go ahead and solve this. It's different looking. Don't let it throw you off. Yeah, we're going to use substitution, absolutely. Sure. You have to make a decision. Do you want to take it as it is? It's already x equals. I could substitute this in for y. Why not just do that? Okay, so instead of writing x, I'm going to write what? Y minus 3. So I have y minus 3 squared minus 9. What? What? Okay. All right, so now what? So now what? Who's at it? Taylor. Your name's Taylor. Cross multiply. Y equals y minus 3 squared minus 9. Absolutely. Cross multiply. Yeah, I got to square out that y minus 3. I got to FOIL it, right? Absolutely. So I get y equals y squared minus 6y plus 9 minus 9. You get very fast at FOILing once you've done it for many, many years in a row. Sure, we can get rid of that. Is it a quadratic? Yeah, we like to get y. We like to get it set equal to 0 if it's quadratic, don't we? Okay, so we get y squared minus 7y equals 0.
That's a good question.
GCF. What's my GCF?
Why?
Good. You have to yell at me. Y. Y minus 7 equals 0. What is that rule called? What's the rule? What's it called? No. Zero. Close. Zero product rule. Zero product. So we wind up with two values of y. So we've got 0 and we've got 7. Great. That's not so bad, is it? Okay, I've got my y's. What do I need? Need my x's. How do I get them? Yeah, I'm probably going to use this right here, aren't I? I ain't using that other one. All right, so I need to substitute my y's in. Ain't is not a word. We're going to subtract. Right, so negative 3 gives me my first x. 7 minus 3. Yes. So we get these two values. Okay. And I know that you can check it graphically. We're not going to spend the time doing it. Are we okay with this? I have an answer. Okay. So moving on to the next one, we're not gonna check it real quick. Okay, so now let's talk about systems of inequalities. So this is a little bit different, okay? A little bit different with inequalities because instead of just having 1 to 2 solution, we're going to have infinitely many solutions. We're talking about shading now. Remember this stuff? Okay, so if it's greater than or greater than or equal to, which direction do we shade? Up and to the right, okay? So if we graph something and it's greater than or greater than equal to, we're going to shade up and to the right. Got it? Less than and less than or equal to, sorry. In the book, there's an up arrow, or just write up. Less than equal to? Down and left, good. It's where you shade, the direction in which you shade. So if you have something that looks like this, if it's greater than, you would shade up here. If it's less than, you shade down here. Okay. Less than and greater than, what kind of line? Dotted, great. And less than or equal to, greater than or equal to? Solid. Let's do this. Okay, so the nice thing about this is New York State decided that, okay, so the way it stands right now, we have a little bit of an issue because I want to use my calculator to graph these. Good, they need to be y, well, not equals.
Or y,
whatever that inequality is, right? So I need that y by itself. So with this first one, 2y is less than negative 5x plus 10. I need to get y by itself. How? Sure, divide it by 2. So y is less than, do I have Germex? Yes, up here. Y is less than negative 5x plus 10 all over 2. Sure, you could write it as y is less than negative 5 halves x plus 5. Same exact thing, doesn't matter which way you write it, they're equivalent. Okay? Okay, second one. Add the x. So y is greater than or equal to 5 plus x, or x plus 5. Again, same thing, doesn't matter which way you write it. Okay. All right, so yes, now we're going to graph it. So go ahead to the next page. Now, who remembers how to change to the yes, dear? Go ahead. Yeah, we want to change that equal sign. It's not equal anymore, right? We want that inequality. So you're going to hit delete. And up is going to pop our choices here. So the first one is less than. Select it and put in your equation. Now to remember to put in a fraction, control, divide. We'll give you a fraction. So negative 5 halves x plus 5. So there it is. Now, when I click off of this, I notice that my line is indeed dotted, and it's shaded to the left and down. Are we in agreement here? Okay. Go ahead and graph your second inequality. So again, Control G brings back up my function bar. And we're going to do 5 plus x. Hello, no we're not. Just kidding. Greater than or equal to 5 plus x. There we go. Yeah. Okay. Where are my solutions found? Where we're both shaded, double shaded. My double shaded region are where my solutions are found. Okay? All right, question. Is this a solution? Yes. Why? It's on the solid line. If it wasn't on the solid line, would it be a solution? No. Okay, so if it's on the solid, it's a solution. If it's on the dotted, it's not. Got it? Okay, so here are all of my solutions. Now, of course, they extend out, right? This doesn't just end. So how many solutions do we have? Infinite. A lot. Infinite. Okay? It is a lot, I guess. All right, what do you think? Do I need to do more of those? Do we got it?
Yeah.
We're under control.
Yeah.
Take out your homework packet.